Hi, welcome to Wednesdays with Winnie. I'm Winnie Dunn, Distinguished Professor of Occupational Therapy at the University of Missouri. We call our school Mizzou. The faculty at Mizzou are doing really interesting research, and you can learn about this work in presentations and publications. Wednesdays with Winnie are designed to highlight evidence-based teaching tips that Mizzou faculty have found to be great options for professional education. They will be quick. You can watch while taking a coffee break, and then you can discuss with a peer how you're going to move away from lectures and into engaged learning. Today, we're going to talk about using graphs to illustrate the importance of effect size. We've all learned about statistical significance and can identify this finding in research articles. There are two additional statistics we want our students and need our students to understand to get a full picture of the meaning of research findings when applying their ideas to practice. Our students will encounter these additional statistics in their careers, so we need to be sure that they understand how to interpret these scores, both numerically and functionally, for their practice. In addition to statistical significance, we must also consider power and effect size. Power tells us whether there were enough participants in the study to find any differences that might be there. When there are enough participants, the power statistic approaches 1.0, just like a perfect correlation. But power is not the focus of our discussion today. Today we're going to talk about the third statistic, the effect size. The effect size tells us whether the difference in the two groups is big enough to matter in practice. Particularly when there are large samples, total scores can be significantly different pre to post testing or across groups, yet the amount of the difference is actually small. Sometimes the difference is small enough that a therapist or a family member might not even be able to see that difference in performance. I created a simple example for you in the resources with a study about exercise and physical performance in older adults. The slide shows which table I took the data from to create the graph, and the article citation is in there for you as well. I've used a box and whisker plot. Some use the bell curve to show the effect size. I'm providing you with some resources so you can see these options as well. So in this study, they measured several things. One of the things they measured was simple reaction time in milliseconds. For the exercise group, there was a significant improvement in the simple reaction time with a p-level of less than 0.05, which is what we always look for. During baseline, participants had an average reaction time of 291 milliseconds. During retesting, participants had an average of 284 milliseconds in their reaction time. This 7 millisecond difference represented a significant improvement based on the p-score. But let's look at the rest of the story. Effect size considers the magnitude of the difference between the two conditions. To illustrate this, I plotted the means, +1 and +2 standard deviations going up, and -1 and -2 standard deviations going down for each condition. 2 standard deviations above the mean were 399 in baseline and 390 in the retest, respectively. 2 standard deviations below the mean were 183 for the baseline and 178 for the retest. When you look at the slides, you will see that these two conditions overlap considerably when graphed next to each other. It would be very hard to tell a performance difference at retest, even though the numbers are significantly different statistically. Effect size is a critical consideration for practice applications because it tells us whether the difference would be noticeable in practice. In which class might you introduce graphing to illustrate the importance of effect size? What article are you going to pick to graph the tables and see what you find? And who are you going to tell about this strategy? See you next time. You can find more resources at our website.